All right, you guys, up in this lesson would be oxidation numbers. And so we've already talked about atoms wanting to become stable. Most elements want 8 electrons in their outer energy level. They can gain or lose. We've talked about that, looking at valence electrons. And so now we're going to start talking about the oxidation numbers and how elements are going to form different types of bonds. And so we've been through here. This is where I'd like you. We've got a couple slides on oxidation numbers that I want to talk about. So oxidation numbers, here we go. They are positive or negative numbers assigned to an element to show how it combines. And the idea is it's showing if it gained, lost, or shared electrons. Now the thing that's weird about these, we see pluses and minuses, but if you take a look right here, it says plus means electrons are lost. Usually when we see a plus sign, we typically think that is gaining or getting more. Well, in this case, we're talking about the charge, and so if we see a plus sign, it means electrons are lost. And then the number tells us how many electrons. So when I look at hydrogen, the plus means electrons are lost, and the 1 tells me 1 electron is lost. If I look at oxygen, negative sign means electrons are gained, and the 2 tells me it's 2 electrons. I suppose I could go this way for you guys so it's a little bigger. So oxidation numbers work a little differently than what we would normally think. So we just have to get used to that idea. Plus means electrons are lost, negative means electrons are gained. And then the number just simply indicates how many. In a moment, we'll put some labels on our periodic table, but if we look up at the top, that small picture up there shows us oxidation numbers. And we'll put some of these on our periodic table for the various elements, but we see those plus signs and the minus signs, and then on the top, that plus 1 goes all the way down, plus 2 goes all the way down. Transition metals are a little different. We'll talk about that in a little bit. But these numbers apply to the whole group. So just like we wrote the valence electrons on the bottom, and that applied to the whole group, these we'll put up on top and they'll apply to the whole group. But we'll do a little bit more with that in a bit. So each group or family has its own oxidation number. Here's a bigger picture there. Again, this idea that plus 1 extends all the way down the group. So lithium, sodium, potassium, rubidium, cesium, francium, all have plus 1. All of these have plus 2. Transition metals, again, we'll see those in a minute. We'll do something a tiny bit different with those, but yes, they have oxidation numbers like anything else, and some of them are a plus 1. We should include that one in there. Group 3 is plus 3. Group 4 is plus 4. Sometimes it can be a minus 4. We'll see that, so I'm going to put minus up there. Minus 4 or plus 4. Minus 3, minus 2, minus 1. And so groups 1 and 2, 3. Oops. So groups 1, 2, transition metals, and group 3, they want to lose electrons. Usually groups 4, 5, 6, and 7, they want to gain electrons. And remember, noble gases, they're not going to do anything because they already have what they're looking for. They're already stable. So those we're just going to leave alone. And then in a compound, the sum of the oxidation numbers is always a 0. And so we're going to start putting these onto atoms in the compound, and they usually always add up to 0. So here, plus 1, minus 1. Plus 1 minus 1 equals 0. Here now notice H2O. It's a plus 1. But now notice there's 2 of them. So plus 1, plus 1, there's 2 hydrogens, and then a minus 2. That still comes out to be 0. Same idea here. Silver is a plus 1, but there's 2 of them. Plus 1, plus 1, and that minus 2, that still comes out to be a 0. We could do something a little bigger. We could do something like, this is a big one, Al 2, well, aluminum is a plus 3, silver is a minus 2. Let's check this one out. Well, let's see, there are 2 aluminums, so I'm going to go this way, plus 3, because there's 2 aluminums. That gives me a total of 6 positives. Sulfur is a minus 2, minus 2, minus 2, minus 2, because there's 3 sulfurs. Well, that equals 6 negatives. Well, positive 6, negative 6 still comes out to be a 0. So when we add up those oxidation numbers, doesn't matter what the compound is, they should add up to be, the total charge should add up to be a 0. And then there are some, and we'll see this on our periodic tables as well. We just need to know that some elements have more than one oxidation number. The transition metals right here, they don't follow nice, neat patterns. The short columns, as I refer to them, they don't follow nice, neat patterns. And some of those transition metals exist in more than one state. And so something like iron, it might be a plus 2. So we put a 2 in parentheses. Or it could be a plus 3, so we put a 3 in parentheses. So the number in parentheses just tells us the oxidation number. And the metals are always, transition metals are always positive. Plus 1, it's a 1 in parentheses. Plus 1, it's a 1 in parentheses. Plus 2, it's a 2 in parentheses. Plus 2, it's a 2 in parentheses. Something like chromium. It's a plus 2, so I'd have a Roman numeral 2. Chromium can also be this. It's a plus 3, so then I would put a 3 in Roman numerals. So that Roman numeral just tells us if it's a plus 1, a plus 2, or a plus 3.